This is 6.6, the fundamental theorem of algebra. You don't need to write the objective down. What the objective today is to write polynomial functions given the zeros of the function. Sometimes the zeros are real numbers, so those are going to be your x-intercepts on your graph. And sometimes the zeros are complex, which are imaginary numbers. Remember, imaginary numbers have that letter I. Very important in the red, I do want you to write this down. Complex zeros always occur in pairs. So go ahead and write this down right here in the red. All right, first example. I would recommend you write this down. If you're given a 0 at 2 plus 5i, then you must have another complex 0 with its complex conjugate. We taught you earlier this year what a complex conjugate is. A complex conjugate, you change the sign of the imaginary part. So the imaginary part in 2 plus 5i is the 5i. So we look in front of it, it's a plus. So what is the complex conjugate of 2 plus 5i? So see if you can answer that question yourself. Well, the complex conjugate of 2 plus 5i is 2 minus 5i. We will use this concept later in our lesson when we write polynomial functions. Go ahead and finish writing up that example. All right, given the following zeros, 5, -2, and 4. All of these zeros are real zeros, so they will be x-intercepts on our graph. And what we want to do is we want to write the polynomial functions two ways. We want to write it in factored form, and we want to write it in standard form. So what we have to do to write it in factored form is we have to kind of think opposite. Remember, these are your x-intercepts. So in factored form, let's take the first 0. You should be writing this problem down. The first 0 is at 5, so that's the x-intercept at 5. So to write it in factored form, it's going to be x minus 5. The reason why is if we use the zero product property and set that factor equal to 0, you don't need to write this piece down. If I set it equal to 0 and I solve it, I get x equals 5, which is a 0 of the function. So you don't need that piece. All right, the next 0 is at -2, another real 0. So we write that in factored form. So we think opposite. So it's x plus 2. And then the last 0 that's given to us is at 4. So we think opposite, x minus 4. This function is in factored form. We also want you to convert it to standard form. So to convert it to standard form, we have to distribute those the parentheses out. So we think back to earlier in our chapter, how we FOIL those out is we want to multiply maybe the first 2 parentheses together, clean it up, and then distribute that parentheses to the x minus 4. So let's go ahead and do that now. So the function equals, and we're going to FOIL the x minus 5 and the x plus 2. So x squared x times 2 is 2x. Then we go -5 times x. And then -5 times 2, which is -10. And then we still have that x minus 4 at the end. Now let's combine like terms in that first parentheses. X squared is alone. And then 2x minus 5x is like terms, so that combines to negative 3x. And we have minus 10. Now we're going to go ahead and distribute the first three terms into the second parentheses. So we distribute x squared to x. So we get x to the third. Then we distribute x squared to negative 4. We get negative 4x squared. We go and distribute, I'll change colors. The negative 3x to the x, negative 3x squared, then negative 3x to the negative 4, which is positive 12x. Again, and then our last term, distribute negative 10 to the x, is negative 10x, and then negative 10 to the 4, negative 4, gives us positive 40. Now we're going to go ahead and combine like terms and make sure it's in standard form. So we look for the highest term. The x cubed is the highest term. X cubed, no other x cubes in that equation. And then our like terms are the x squareds. So negative 4x squared minus 3x squared is negative 7x squared. And then I have like terms of 12x and negative 10x. Those combine to 2x. And then I have my constant at the end, plus 40. Notice that we had 3 zeros in this function, and now my function's degree is 3. Later on in the chapter, we're going to graph these polynomial functions. Let's go on to the next example. You don't need to write this box down. You already have it in your notes, but I just wanted to review with you. When you have complex zeros, again, they occur in pairs. So here's our question. You are given a 0 at 3 plus 2i. Where will you have another 0? And it's blank there. See if you can answer that question. Where will be the other 0 in the function? Well, we're going to have a 0 at the conjugate, so we look at that symbol in front of the I term. So we will have a complex 0 at 3 minus 2i. Remember, those are not x-intercepts on the graph. They're still zeros of the function, but they're not x-intercepts. So let's go ahead and write this polynomial in factored form. So when you are going through and writing this problem down. So f of x equals, I'm going to put a bracket here. And now remember, we have to think opposite. So x minus my 0. So I'm going to take this first 0, 3 plus 2i. So there's the first 0 in factored form. I'm going to make another bracket here. And then I think opposite. So 3 minus 2i is the other 0. So remember, it's always x and then minus 3 minus 2i. That question now is in factored form. We want to convert it to standard form. This is a little bit of a challenge, so you'll need to watch closely on it. So what we want to do is we want to FOIL this question. So it's a good idea maybe to distribute that negative through the parentheses. So let's do that next. So I distribute the negative through. So I get x minus 3 and then minus 2i. Distribute the negative through. minus 3 plus 2I. Now what I do in these problems is I group the real pieces together, the x minus 3's together, and the x minus 3's together. Now what we have to do is we have to FOIL this. Be very careful here. So we're going to multiply the first two parentheses, that's the first term. So x minus 3 and x minus 3 is x minus 3 all squared. Then we go to the outside. X minus 3 times 2I. Now we'll distribute the negative 2 to the parentheses. Negative 2 times x minus 3. And then negative 2I times 2I. I'm going to stop the recording there so we can finish this problem. We're at 11 minutes.